Good evening, everyone. How are you this evening? So, does anybody have any questions on anything that they've been working on during the week and have questions about? Okay. So, what I want to go over is identifying functions, whether they're functions or not, and whether they're valid or not. So, this is one of the most missed questions, and it's almost on every exam. So if you look at number one, you have 5 tables. Okay, so we're going to go through each one and determine if the table is a function or not. Okay. Does anybody know the rule when something is a function?
The X is, you can't have two of the same.
Right. So for every X, there's only one Y. So for every X, there's only one Y. Let me change it to red. So this first one, is this a function or not? This one here.
Not a function.
Why is it not a function?
Because the two repeats.
Because exactly, so not a function. How about the next one? Is that a function?
Yes.
Yes, this is a function because for every X, there's a different Y. So remember, one of the mistakes that people make is the X's can't repeat, the Y's can. So the third one, is that a function?
Not a function.
Why not?
The ones repeat.
The ones. How about the next one?
Not a function.
They repeat several times. And how about the last one?
That's a function.
Oh, yes. Okay, so that's using the table. You are going to probably get a problem like that. How about if they give it to you as a point? So let's go. Let's just do the first three. Is A function?
Not a function.
Why?
The twos repeat.
So the only difference is they're giving you the same information. The first way they gave it to you in the table. The second way they gave it to you in points. So these set of points can also be written as a table. 2, 2, minus 2, 7, 2, 4, minus 2, 9. So the 2's repeat and the minus 2's repeats. So it's not a function. How about B?
Function.
Function. None of the X's repeat. So it's a function. All right, so that's good. It's almost on every exam. Okay. Third way is if they give you a graph. You're not going to worry about. So one of the things you want to remember about a function you might have heard is called the vertical line test. So if you can draw a vertical line and only pass through one point, then it's a function. That's visually. Okay. So all these examples here, can I draw a vertical line and only pass one point? Not a function. Now, they really don't give this to you in the GED. This is for the high set or task, but now you know. It's called the vertical line test to test something if it's a function or not. So if you draw a vertical line and it passes through more than one point, it is not a function. But the one I want you to be familiar with is this one here. And let me show you. Let me increase the zoom. Is this one right here? This is more of an indication of a problem that you may get on the GED. Of course, this is my x-axis. This is my y-axis. So is this
That's
graph
not a function.
how do you so if we label these, it'd be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Number 8.
So if you look at 8, you have 2 points, whatever that is. It doesn't matter that you know the y's. All that you know, remember, for every X, there's only one Y. So when X is 8, you have 2 different Y's. Perfect. Guaranteed question. You're going to see it. Guarantee you're going to see one of those. Okay. Another problem I saw during the week was exponents. Okay. So let's look at, I'm going to find one real quick. Let's see. Let's look at number, I don't like any of these. I may have to make one up. Yeah, I'll make one up. I will make one up. 8, A to the 7th, B to the 4th, C to the 3rd. 2, A to the 5th, B, C squared. Okay, so one of the mistakes I saw a lot over the weekend, people did not reduce and understand and use the power exponents. Remember, we have certain rules. So what are some of the rules for exponents? What's some of the rules for exponents? What is a 5 to the 0 power?
1,
1.
5 for 1.
What's 8 to the 0 power?
I ain't
What's
hear
1.
1. So that rule is anything to the 0 power is 1. Okay, what's 5 to the 1st power?
5.
5. Okay.
1.
And A to the 1st power is what?
1.
Nope, not 1. So remember, you said 5 to the 1st power is 5. A. Because you notice I'm using numbers, actual numbers on the left side, and I'm using variables on the right side. The same rules apply. What if I have 5 to the 3rd times 5 squared, and I want to keep this in exponent form? I don't want the actual value. I want to keep an exponent form. What is 5 to the 3rd times 5 squared?
5 5 is 25.
Right, 5 is 25, but I don't want the actual value. So what you want to remember is when you have
5.
you are multiplying exponents with the same base,
Oh.
you add the exponents. So this is 5 to the 5th power.
5
Why?
to the
Because
5th.
3 plus 2 is 5.
All right.
Okay. So say if I had
5 to the
A to the
5th.
7th times A to the 3rd, what's that equal to?
8 to the 8 to the 10th.
A to the 10th power, because you're adding the exponents. If you're dividing, so I'm going to do it for you, 5 to the 9th divided by 5 to the 3rd. So if you look at it, we would have 5 times 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 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Divided by 5 to the 3rd. 5 times 5 times 5, because that's what an exponent is. So you have your base and you have your exponent. So the base is multiplied, whatever the exponent n times, right? So 5 and 5 cancel, 5 and 5 cancel, 5 and 5 cancel. How many I have left? 1, 2, 3, 4, 5, 6. So this will be 5 to the 6th power. So what you should see, remember I told you math is about patterns. 9 minus 3 is what? 6. So when you're dividing exponents with the same base, you subtract top minus bottom. 9 minus 3 is 6. So this answer is 5 to the 6th power. So what if I had A to the 10th divided by A to the 4th? What would my answer be?
A to the power.
To the what power? To what power? I'm sorry.
I can't see it, Mr. Timmy. Can you put it over here?
A to the 10th divided by A to the 4th.
A to the 10th. A to the 4th. A to the 6th.
A to the 6th. Because why? 10 minus 4 is 6. Okay. So these are certain rules you want to remember. Now, if I have, and I'm going to just use a variable now, or I could do it. I say 2 to the 3rd, all raised to the 2nd power. So anytime you raise, it's like you multiplying the same thing twice. So that's 2 to the 3rd times 2 to the 3rd. Again, we know how to multiply exponents with the same base. We add it. So 3 plus 3 is 6. But what you should notice is when you raise to a power, you multiply the exponents. So 3 times 2 is 6. So what would a to the third raised to the third power be?
A to the 9th.
A to the 9th. Why? Because you multiply 3 times 3. Okay. And the last rule I want to show you is, I'm running out of room here, so I'm going to have to erase. Right. You're correct, Annie. To the 9th power. So if you are new, make sure you put your email in the chat, so I'll be able to send you the video. And the last rule of exponents. Now, this is going to be one of your first 5, but the rule of exponents you're going to need throughout mathematics. This is a necessary skill. You must know your exponent rules. The last exponent rule is if you have a negative exponent. Very easy. For example, a to the negative 5th equal 1 over a to the 5th. 1 over, 2 to the negative 2nd will be 1 over 2 squared, which is 1 over 4. So if you notice, I'm going to give you a nice little trick. Reverse the orientation. So, for example, a to the negative 5th is on top. You put it on the bottom. You change the exponent sign. So, for example, if I had c to the negative 3rd over d to the negative 2nd, since c to the negative 3rd is a negative exponent and it's on top, I'm going to put it on the bottom and change my exponent to positive. When I look at the denominator, d to the negative 2nd, my exponent is negative. So since it's on the bottom, I'm going to put it on the top and change the sign of the exponent. So those are your exponent rules. You have to know them. You guarantee another guaranteed question on your exam. Probably one of the first 5, but you're also going to need it when you're multiplying binomials, and throughout algebra, you're going to need how the exponent rules. So when we look at this, when we try to solve this problem, what will we do first to solve this problem? Anybody know?
Yes.
Tell me.
You say 2 into 8.
Okay, so you look at the numbers first. So 8 divided by 2 is
2 into 8, 4.
Okay, then what's next?
And then you say 5. 5 into 7.
No.
5 from 7. 5
from
subtract
7.
5 from
Correct.
7.
Remember, because we got to use the exponent rules. When you're dividing exponents with the same base, when you're dividing, you subtract. So 7 minus 5 is 2. So a to the 7th divided by a to the 5th. It's almost like you're looking at each one of these separately. So then we have a squared. So 4a squared. Then we're looking at the b's. So we got b to the 4th over b. Now, what a lot of the mistake that a lot of people make is when they don't see an exponent, they think it's 0. No, when you don't see an exponent, it is a 1.
b to the 3rd.
B to the 3rd. And then we look at the last group. C to the 3rd divided by c squared, which is what?
C.
Just C. So your final answer will be 4a squared b to the 3rd times c. Again, you have to know your exponent rules. Okay? So I want you to go over them. That's a guaranteed question, one of your first 5. Okay. The next thing I wanted to look at was factoring a quadratic equation. I've marked about 11 or 12 quizzes or practice tests, and a lot of people got this wrong. So I just want to revisit it real fast. So the first thing you want to realize is the standard form of a quadratic equation. Can anybody tell me the standard form of a quadratic equation? Can anybody tell me the standard form of a quadratic equation?
Is a plus ax squared plus bx equals c plus c equals 0.
Ax squared plus bx plus c equals 0. So if you keep that in mind, I'm going to show you something. Watch this. Let me make this bigger. You keep that in mind. If you know Put that right over top. So what you do is you identify your A, B, and C. So your A is what?
X squared.
What coefficient or what number is in front of the X squared?
1.
1. B is what?
-7.
-7. C is what?
-18.
-18. What you realize sometimes when you look at this, what causes confusion is, hold on, Mr. Tiz, I thought you said standard form was ax squared plus bx plus c equals 0. Well, this doesn't have equal to anything. So when you see something like this, what you're doing is you assume it is equal to 0. They don't give you an equal sign. They just have the quadratic equation, assume it's equal to 0. So now A is 1, B is -7, and C is -18. So if A is 1, we're going to factor or find a factor pairs of C or find a factor pairs of -18. So what two numbers can I multiply together to get -18? Can anybody help me?
9 and 2.
Well, let's start with 1. 1 times what?
I'm sorry. 1 times 18.
What kind of 18?
-18.
-18. 2 times what? Two times what to give you -18?
Oh, sorry, 9.
What kind of 9?
-9.
Can't forget those signs. 3 times what to give you -18?
6. -6.
-6. 4 does not go into 18. 5 doesn't go into 18. 6 goes into 18, but we already did 6. Okay. So now we go on the other side and we're going to change the signs of the pairs on the first side. So instead of 1 and -18, what are we going to have on the second side?
Could it be 1 and +80? 18?
So -1
18?
and positive 18.
Yes.
So we're just changing the signs. Right,
Yes.
you're correct. And then what's the second pair?
2 and 2?
2, you sure about 2? Remember, we want to change the signs from the left side. So instead of
I'm
2, we're
sorry.
going to have
I'm sorry,
what?
-2 plus
-2
9.
and 9. And the third pair is going to be what?
-3 plus 6.
-3, not -3 plus 6, -3 and plus 6.
And
Right, you
plus
don't want to say
6.
-3 plus 6 because it seems like you're adding them or something. So now we have
No.
all our factor pairs. So we have 6 pairs. So our next step is to find the pair that's going to give us -7. Which pair, if we combine together, will give us -7? Which pair, if we combine together, will give us -7?
The second pair.
The second pair. So this right here. Why? Because 2 minus 9 equal -7. Okay. So now that we have our pair, we now can factor this quadratic equation. We're going to use that pair. So our variable is x. So the pair that we selected was +2 and -9. So x plus 2 times x minus 9. This is how you factor a quadratic equation when the coefficient of your highest degree is 1. This works when your highest degree is 1, not when it's like 2x squared or 5x squared. Okay, it takes a much. So this is how you factor. This is the answer factor. Okay, this is the factored form of this quadratic equation. Now, what I also want to show you is how to solve this problem, because sometimes they ask you to factor the quadratic equation, and sometimes they ask you to solve it. You gotta pay attention. Sometimes they ask you to factor it. Sometimes they ask you to solve it. But guess what? If you factor it, you can solve it. So you got to find your zeros. What that means is what values of x would make this 0. So if you look at this first, x plus 2, what's the opposite of plus 2? What's the opposite of plus 2?
-2.
Minus 2. What's the opposite of minus 9?
+9.
Positive 9. Why? X plus 2 equals 0. In order to get x by itself, we subtract 2 from both sides. X equal -2. Same thing for x minus 9. Set it equals 0. X minus 9 equals 0. In order to get x by itself, we got to add 9 to both sides. X equal 9. What I gave you is just an easy way to look at it. Once you have your factored form, your quadratic equation, you just take an opposite. Opposite of plus 2, -2. Opposite of minus 9, plus 9. So that's how you factor a quadratic equation and solve a quadratic equation when your coefficient of the highest degree is 1. But guess what? This is the mistake that I saw a lot of people making over the weekend. Let me find it. So example like this. So again, this is on Schoology. You can, take these as many times as you want. Okay, so if you notice, it says factor 6x squared plus 9x minus 15. Can everybody see that clearly?
Yes.
Okay, so what I would do is I wouldn't try to factor this. If I were you, I wouldn't try to factor this. Well, Mr. Tinsey, well, how are we going to get the answer? I'm about to show you. When they give you the multiple choice, if they're asking you to factor, and this is not equal to 1, and they give you multiple choice, what I would do is I would multiply binomials for each of the multiple choice. So one thing you should know is that the last term is minus 15, and the first term is 6x squared. So if I multiply 3x times 2x, what is 3x times 2x?
6.
What is 6 what? Six what?
Oh, I'm sorry, 6 to the 3rd power.
Not to the 3rd power.
Second power.
To the
Second power.
Because why? X times x, remember, you got a 1. Exponents with the same base, you add the exponents. 1 plus 1 is 2. Remember, I told you that exponent rules are very important. You're going to need them. So 6x squared. So we know that each one of these, the first term, is going to be 6x squared. We can easily see that. But the next thing I want you to do is look at the last term, minus 15. So we're going to look at the last two. What is plus 3 times 5? What is 3
Plus 3.
times 5?
15.
15. So we know it can't be A. Because why? Our quadratic equation says minus 15. What is plus 3 times minus 5? Again, you can get minus 15.
Minus
right?
15. Yes.
So that's good. It could be B. This is a possibility. It could be B. Let's look at C. What's minus 3 times minus 5?
Positive 15.
Positive 15. So we know it can't be C. So now, say you didn't even know how to do this problem. Just being able to multiply, knowing the exponent rules, we can figure out and get it down to a 50-50 chance. We know the answer is between B and D without even knowing how to do it. So let's make sure we know how to do it, though. So what we got to do is we got to multiply binomials. A lot of people have problems with this concept. Okay, well, what is a binomial? What does bi mean? Bicycle has how many wheels?
2.
2. Bi means 2.
2.
Okay, so 2 terms times 2 terms. Okay, monomial is 1. Polynomial is many. So this first option is 3x plus 3 times 2x minus 5. Let's try it. We already know 3x times 2x. We said that was 6x squared. What's 3x times minus 5? What's 3x times minus 5?
Minus 15.
Minus 15 what? 3x times minus 5. Minus 15 what?
15x.
15x. What's 3 times 2x?
6x.
6x. And then 3 times minus 5 is minus 15.
Minus 15.
We have a like terms here. So we got 6x squared. What's minus 15x plus 6x? Minus 15x plus 6x.
Negative 9.
Negative 9x. So negative 9x minus 15. Well, we know that's not it.
No.
Because our middle term is plus 9x. So we now know it's not B. We know it's not A. We know it's not C. Our right answer must be D.
D.
So my recommendation is if you get to a problem like this, instead of trying to factor this quadratic equation, use the multiple choice and using the concept multiplying binomials and do each of the multiple choice and you can find your answer. Because if you got to factor this, it takes a much longer time. It's a much more difficult problem. Everybody understand that? Okay. Next one. What was the next one? Factor. Where was it? Oh, I closed it up. I didn't mean to close that up. Did I close it up? I sure did. Let me see if I can find it. It was another problem that people had difficulties with. I shouldn't have closed that one up. It was right there. Hey, Bridget.
Yes. Hello, you can hear me?
Mm-hmm.
Oh, okay, cool. Did you get
You
my
know what?
message?
Yes, I got it. Don't have me worried about you.
Huh?
I said, don't have me worried about you.
Oh no, I'm good. I'm good. I'm good.
Okay,
I'm good.
good.
Okay. I've been trying to get on and get off, get on, get on. But
Mhm.
I've been had so much on my mind, but I'm back.
Good. I'm glad to hear that. I can't find the one I'm looking for. Where are you? Give me 1 second. Is it 3? It might be 3. It might be 4. It might be 5. Okay. So and I've had a couple people during this week send me a similar problem or have issues with this. So I want to make sure I covered it and people understand. Okay, so let me find a problem. I might have to just make one up, but if I can't find it in a couple of seconds, I'll just make one up. It's not that one. It's definitely not that one. Definitely not that one. Okay. Let me see. I'm gonna give about 10, 15 more seconds. If I can't find it, I'll make one up. All right. Okay. Okay. All right. I can't find it. I'll make one up. Oh, is that it? I think I might have found it. Come on, cross your fingers. Come on, come on, come on, come on. Is this it? Is this it? This is it. I found you. Okay, so I want to show you this problem here. Let me put it on the screen. Let me make it big enough so you can't see the answers. It says, perform the indicated operation and express the result in simplest terms. So you do have multiple choice. It has to show you the answer, but I'll show it to you. Okay. Would anybody know how to do this problem? It says, put it in simplest terms, x over x plus 3 plus 3x over x squared minus 9. Does anybody know how they would even start that problem? Like even to begin how to do that problem? Because
Yeah,
who said yes? Who said yes?
Bridget, I think I do.
Okay. Bridget, how would you think you even start this problem? Please tell me.
Well, I will try to find my denominator.
Yes.
So
what she said was, hold on for 1 second. So what she said was, remember, this is a rational expression. It looks like a fraction. That's all a rational expression is. It can be displayed like a fraction. So remember the important rule about fractions. In order to add or subtract fractions, you must have a common denominator. Very good. What's next?
Well, I see x squared minus 9 can be factored.
Okay. So if we factored x squared minus 9, what could we factor that to?
X plus 3, x plus minus 3.
Perfect. So what she notices, this is called a difference of squares. What I mean by a difference of squares is that there's no middle term because the middle term is canceled out. So when you have a plus 3 and a minus 3, so x plus 9, x minus 9 will be an example. So x plus 9 times x minus 9 will be an example of a difference of squares. So you know the answer is just x squared minus 81. There's no middle term because that plus 9x and a minus 9x cancel each other out. Everybody understand that? So now you have that difference of squares on the bottom. So one denominator is x plus 3. The other denominator is x plus 3 times x minus 3. So what could we do so the denominators are the same?
Add x plus minus to the other side.
Add what? Say it again.
Add x plus 3.
Sure about that?
To the other side of x plus 3. Wait, I'm sorry. Add x minus 3. Add it to with the other side, x plus 3. So my denominator going to be x plus 3, x minus 3.
Right. So what you're going to do is, since you want the denominator to look like this and they're being multiplied, that means you need to multiply over here by x minus 3. Now, remember the rule. Whatever you do to the bottom, you do to the top. So we multiply the left term by x minus 3 on both top and bottom. So now we'll have x times x minus 3 over x minus 3, x plus 3, plus 3x over x plus 3, x minus 3. Does everybody understand that?
Yes.
Okay. So now we got to multiply that numerator. What is x times x?
2x.
Nope.
x2.
What's x? No,
X
not
squared.
x2. X squared. So x2 or 2x are the same thing. We want to raise to a power. It's either x squared or x to the second power. So x squared. Then what's x times minus 3?
Negative 3x.
Negative 3x over x minus 3, x plus 3, plus 3x over x plus 3, x minus 3. When we have the same denominator, we can then combine the numerators. So just like a fraction, once you have a common denominator, you can combine the numerators. So we notice now we should have x squared minus 3x plus 3x all over x plus 3, x minus 3. What is 3x minus 3x?
Cancel it out.
They cancel each other out, and you get x squared over x minus 3, x plus 3. And now, if you notice, all the denominators have x squared minus 9, so they multiply this out. So x squared over x squared minus 9. So that's the answer we're looking for, which is D. A lot of people, matter of fact, over the weekend, I don't think one person got this correct. Okay, so I'm gonna have some more examples next week. We'll do a little bit more practice next week to make sure we got it. So, but that's Bridget, that's very good.
I still don't
Okay.
understand it.
Okay, so
I
let me
still don't
let me make it a
understand
little
it.
simpler for you, right? Watch this. So I got 1/2 plus 1/5. That's not, they don't have like denominators, right? So you want them to have the same denominator. So what happens is I got to multiply this right side by 2 over 2, and I got to multiply this left side by 5 over 5. Why? Because the least common multiple is 10. So then I have 5 over 10 plus 2 over 10. Now that I have a common denominator, 5 plus 2 is 7. But the only difference is we didn't actually use numbers. We used expressions. So let's look at it again. I didn't save that. So here, what we noticed is they don't have the same denominator. One denominator is x plus 3. The other denominator is x squared minus 9. So what Bridget said is I noticed that the second denominator is a quadratic equation. So I'm going to try to factor that quadratic equation. So she realized that it was a difference in squares, and she did x plus 3, x minus 3. So she changed the way that denominator looked. Now that we have the two denominators, one is x plus 3, the other denominator is x plus 3 times x minus 3. So the difference, let me change my color to blue, is this x minus 3 right here. And it's being multiplied by x plus 3. So we're going to do the same thing on the other side, as we're going to multiply the other rational expression by x minus 3. But we just can't multiply by x minus 3. Whatever we do to the bottom, we got to do to the top. Why? Because anything over itself is 1. So x minus 3 divided by x minus 3 is 1. Anything times 1 is itself. So we multiply both sides by x minus 3. So here we have x times x minus 3. So what I did is I reversed it so it makes sense. So x times x is x squared. X times minus 3 is minus 3x. This is where we got this from here. The 3x we just brought down. We didn't change anything. But now they have the same denominator. Just like we did with the fractions in that previous example, now that they have the same denominator, we can combine the numerators. So x squared minus 3x, which is right here, plus 3x, which is right here. Minus 3x and plus 3x are opposites of each other, so they cancel each other out. So I'm left with x squared over x squared minus 9. And again, that takes some work and it takes some practice. Let's do another short example real quick.
Wait, Mr. Tinsley, can I ask a question?
Yes.
Okay, back to that problem. Because I'm not sure, I think is it a shorter way you can do that if you plug in a number? Well, let me show you something. Can I show you something? Okay, say your problem, x over x plus 3 plus 3x over x to the square minus 9, right? Okay, you was to store a 2 in there in your calculator. So I'm gonna store a 2 in my calculator, and then I'm gonna take that same question, that problem, x over 3, no, x over x plus 3 plus 3x over x squared minus 9. Okay, my target going to be 2, right? Okay. Wait, my target is, that's going to be my answer. Negative 4 over 5, right? And then, so that's going to be my target answer. So what I'm going to do is I'm going to go ahead and plug in, since the 2 stored in my calculator already, I'm going to go ahead and do all the answers until I get negative 4 over 5, and that'll be my answer. You can do it that way too, right?
Yes, you can. I love it. You better stop playing.
Yeah.
I love it.
I seen that somewhere on the computer, because I've been having problems with these problems, and I ran up to, I don't know what website it was, but I found it and I wrote it down, and I've been working them out like that too.
But the problem is, what if they don't? What if now that works, and you can also do for the exponent rules, you can do it that way too. So one of the things
sometimes it works, right? Sometimes it works and sometimes it don't, right?
So one of the things you realize is that when they give you multiple choice, this is very important for you to understand. And this is why multiple choice tests, to me, are a little easier. So what Bridget is saying was, listen, say I don't know how to do all that stuff. I don't know how to, I don't know how to do it. But what I know is that an equal sign, whatever my answer is, must be equal to what I have up top. So I'm just going to put a random, because I know how to use the calculator. I know how to store a variable. So you know what? I'm just going to put a random number in that expression up top. And then I'm going to do the same thing for each of the expressions in the multiple choice until I get the same answer. And then when I get the same answer, I know that is equivalent. So now, is that solving algebraically? No. But would you get it right on the test? Yes. So an example of that is something like this. Let me show you. I'm going to show you a nice example, because I actually had a student in the past do the same exact thing, because he said, remember, what did I tell you? Math is about patterns. When you know what an equal sign is, that means whatever you get must be equal to whatever that other expression is. So if you plug something in, you must get the same answer. So that's the answer behind it. But I'm going to show you something. So this one of my students had this problem here, right? So let me increase the zoom, right? He could not understand the exponent rules. So what he did was he did this. First of all, let me save that. Let me clear everything out. Look what he did. And this is Bridget, this is along the same lines of what you just said. Watch this. So I'm going to take this right here, and I'll put it exactly the way I see it. So 2 to the 9th times 3 to the 5th. And again, this is knowing how to use your calculator. This is practicing enough to where you know how to use it. 2 to the 4th times 3 raised to the 2nd power. And he got his answer. Whatever that answer is, it's an enormous answer. But then all he did was go to each of the multiple choice until he got that answer. So 6 to the 20th. Is that the same answer? No. He went 6. So if he knows 6 to the 20th is not it, you know 6 to the 24th is not it, because 6 to the 24th is even bigger. So then he went to the third one, said, okay, 2 to the 13th times 3 to the 7th. Did I get the same answer? No, I did not. Then he went to the last one. 2 to the 17th times 3 to the 7th. Did I get the right? Did I get the same answer? Now, ding, 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 ding. Look at that. Remember that first one was right there. So then as he went down to multiple choice, he waited until he saw the same answer. So what you are saying is very important. What I told you is math is about patterns. So if you know one of the multiple choice is the answer, you could do that and it would work. Will it work for every number? It may not, because if you have a denominator like x minus 5, for example, when x is 5, that would make that undefined. So you couldn't do it with x is 5. In the next example, you had x plus 3 and x minus 3. You couldn't put plus 3 or minus 3 as x, but you would have to know that. So let me explain what I mean by that. So let me show you, because it's very important to know this. If I know what undefined means, that means my denominator cannot be 0. So the opposite of plus 3 is minus 3. So you can't use minus 3 and store it as x and get an answer. Why? Because it would be undefined. So that second denominator was x plus 3, x minus 3. So you know you cannot use x as minus 3 or plus 3. You cannot use either one of those, but you can use any other variable, any other number, 2, 4, 5, 8, 10, 11, 12, and you would get the same answer that way. I would rather you know the exponent rules. Now, but one key question that Bridget just brought up. To learn how to do this may take you 2-3 days of working with just this. But now, if you know how to use the calculator and store a variable, you don't have to spend 2-3 days how to figure this out, because now you know how to manipulate and use the calculator to get your answer. That's what real life is about. Real life is sometimes not finding the way this person did it. Maybe I build my house a little differently. So yes, that is a way you could solve it. Now, as a math teacher, I would rather you do it algebraically, but hey, you got to pass this exam and it comes down to one question, and that's how you got to figure it out. Do it that way. So here's another example real quick. Let me make this, and this is a little easier, and this is the level of what probably the GED would give you. I don't know why it's not getting bigger. There we go. So again, one denominator is x, the other denominator is 2x. So if I want to have a common denominator, what would I do? What would I have to multiply this first equation by for the denominator to be 2x? What do I have to multiply x by to get the denominator of 2x?
2.
2. Real easy, 2. So now, whatever I do to the bottom, I do to the top. Right? So I got 2a over 2x plus b over 2x. Since they share a common denominator, I can add the two numerators. So 2a plus b over 2x. Most people got this problem wrong too. Again, you got to find that common denominator. So your question is though, right? Let's try it. Let's just try what Bridget said. Let's just take a variable. But hold on, Mr. Tinsley, we don't just have one variable. We got A, we got B, and we got X. So now what we decided to do, can that still work? Yes.
Yeah. Yes.
You can pick any numbers you want. So for example, I could say,
2,
grab
3,
my
4.
calculator. Grab my calculator. This is why I push clear. Again, knowing how to store a variable is very important. I'm just going to say 3, 4, and 5. 3, store A. 4, store B. 5, store C. I mean X. X. Boom. Well, there was storm. Doesn't matter, right? So, in D, A over X got to get out of the fraction, plus ND B over 2x. What do I get? Let's see. Got to get out of my fraction. I get 1. So what I'm going to do is I'm going to use each of the multiple choice until I get 1. So let's try the first one. ND A plus B over 3x. Get out of my fraction, press enter. Did I get 1? Did I get 1? Did I get 1?
Yes.
I did get 1?
I don't know. I can't see real good. Is that a 1?
Did I get a 1? Let's see, make it bigger.
No.
No.
You got 7 over 15.
I got 7 over 15. So we know it's not A. So I'm going to go to my
Right.
second choice. ND 2A plus B over X. Did I get 1?
No, you got 2.
No. So I'm going to go to my third multiple choice. ND A plus B over 2X. Did I get 1?
No.
No. Let's go to my last one just to prove it to you.
Mm-hmm.
2A plus B all over 2X. Did I get
There
1?
it is. Yep.
There you go. So is your answer, yes, you can do it that way. Because what they're telling you is, and that's one of the advantages you have when you're taking a multiple choice exam. If you have a multiple choice, one of them is the answer. So guess
Yes.
what? You can use that same thing on area, volume, all those different problems. Use your formula, plug something in until you get the right answer. You can do it that way. Yes. Now, would I recommend that way if you want to go to community college or post-secondary school afterwards? No, I wouldn't, because this is a concept you should know. But if you're trying to get this problem, taking this GED to pass the GED, could you use it? Yes, you could. That's a lot of work, though. But you got it right.
Tinley, the way how you store the, can you explain the way how you store the variables?
So that means you ain't been in your eBook.
No. I know how you store. I know how you store it.
Okay, so
I
if
know
you know
how
how to store it, tell me how to store X's 5.
Okay, you push. You push. You said 5.
X is 5.
Then you go to store. And you press enter. And you say X is 5.
No, you hit your variable. You hit your variable button first.
Yes, you hit your variable button.
This is telling the calculator
X.
5 till it goes X. So if you want it to be A,
and then you
would say
store it.
5 store, and you keep hitting it till you get A. If you wanted 5 to be B, you would say 5 store and hit the variable button until you get B.
Yes.
Now, being able to store a variable will help you on probably 5 different questions to get it right.
Okay.
Because they're going to ask you explicitly, if A is something, what's this answer? Or A and B is something. Remember, if you want to evaluate a function, you can store a variable. If you want to evaluate an expression, you can store a variable. If you want to, if they give you the multiple choice answers for a quadratic equation, you can store the variable. So if you know how to store a variable and you understand what an equation is, that's at least 5 questions. At least, without doing all the hard work.
So, Mr. Tinley, go back up to the first one. You store A as 2.
It doesn't matter what you store.
A over X plus B over 2X.
So
you
all
store
you have
A as 2.
All you have to do is, it doesn't matter what they are. All you have to do is look at the denominator. And you got to make sure the denominators will not make it undefined. So you got to make sure the denominator is not 0. So in this case, it could be any number except 0. Here. So remember, we had that other example was like 5 over X minus 3. I don't know what it was, but plus, I don't know, 6 over X plus 3, X minus 3. Remember, you have to understand, that's why math is important. the concepts are built on each other. Undefined means your denominator can't be 0. So when you choose for X for a value, it can't be +3. It can't be -3. And again, +3 again. So these, now since we already have +3, your X, you cannot store X as -3 or +3. Why?
Okay.
Because it'll make them undefined.
Okay.
And then you couldn't do this problem. Like if you actually did that on the calculator, let me show you. Watch this. I'm gonna show you. And this is why when I go through the ebook, this is why I go through all these steps: how to do a fraction, how to do scientific notation. So as you know how to do this, use this calculator, when you know what an equation is, you already know. Hold on, the multiple choice answers, one of them is the answer. So if I know my formula, let me plug in the multiple choice answers until I get what I'm looking for. So, for example, if I had X is 3, so 3 store X, and I have ND 5 over X minus 3, right? Watch what happens. Because again, if you cannot divide by 0, it makes it undefined. So what Bridget expressed and explained is that, hold on, I know me trying to understand these rational expressions is just too hard. It's blowing my mind. But what I do know is that they're giving me the answers. And I know whatever I get on top should be equal to one of those multiple choice answers. So you know what? I'm just going to throw some numbers in there. Because an expression is a variable. It could be anything. It's an unknown number. It could be anything. So just you can put anything there. As long as that denominator is not undefined. And then you plug into the same things in the multiple choice until you get the correct answer. But that's, you know, that's a way around. But hey, I'm not going to knock it. Listen, it's a whole lot of people that got 144 that wish they knew that trick. So I'm not going to knock it. But now, if you're going to take the TEAS test, the nursing exam, post-secondary school to get your associate's degree or something like that, then you need to know how to combine rational expressions. That's not going to work.
Hi, Mr. Tinsley.
Huh?
Did you get my email?
About the TEAS test?
No, about, I was asking you, could you go? I know it's too late now. I didn't want to interrupt your class, but I wanted to some statistics like bar charts and pie chart. But I guess you don't have enough time.
When you go in Schoology, go under tables, charts, and graphs. I got a whole section of tables, charts, and graphs.
I wanted in-depth explanation,
so
but I'll do it. No problem.
When you talk about statistics, what they're going to give you is mean, median, mode, range, frequency, histograms. That's what they're going to give you in terms of what you're studying next for. Tables, charts, and graphs is always going to be important. But for statistics, they're going to do mean, median, mode, range, frequency tables, and histograms.
Okay.
So on the GED, you don't have a whole lot of, you might have one histogram, like maybe. Frequency tables, you might have one, if you might have one. But for those other exams, you want to be prepared, but you got to make sure you know ratio and proportions. Make sure it's that. All right, so definitely. It is 7 o'clock.
Yeah.
Let me see. I thought I had one more. Hold on. Let me see if I found that last one I wanted to find. It was one more I wanted to go over. Where was it? Oh, yeah, here it is. I mean, here's the test. Hold on, let me open this up right quick. And again, this is algebra. But I wanted to make sure, again, my computer is so slow. My son is playing that Xbox, so he's probably taking all the bandwidth. Them kids play for that game for hours, don't they? All right, I might have to make one up. Let me see. Let me just make one up. Oh, what? Well, my internet connection is unstable. Let's see. All right, let's see. Say this was 13. I'm just making this up. So minus 2/3 x plus 9 equals 13. A lot of people have problems when that coefficient was a fraction. Would anybody know how to solve this? What would be the steps for me to solve this algebraic equation for x?
Subtract 9 from 13.
Subtract 9 from 13. So you get minus 2/3 x. The 9's cancel, equal 4. What is my next step? Minus 2/3 x equal 4.
Division.
Division. Why division?
Because whenever you time something, the next step is divide.
Well, this is what you got to remember. You're multiplying. What does multiplying by negative 2/3 mean? So watch this. I'm going to show you something. So say if I had 9 times 2/3. So 9 times 2 is 18 over 3. 18 divided by 3 is 6. So when you're multiplying by 2/3, you are really doing two operations. You're multiplying by 2, then dividing by 3. Everybody understand that?
Yeah.
So when you're multiplying by negative 2/3, what is the opposite of multiplying by 2?
Dividing.
Dividing by 2. What is the opposite of multiplying by 3? I mean, dividing by 3.
Dividing.
So what we want to do is we want to take the reciprocal. So we want to multiply by negative 3/2. Whatever we do on one side, we do on the other. So now the 2 2's cancel, the 2 3's cancel, 2 negatives make a positive. So we have x equal negative 12 over 2, which is negative 6. So anytime you have a fraction as a coefficient, you want to multiply by the reciprocal. So for example, if I had 1/3 x equal 9, I'm going to multiply by 3 over 1. Whatever I do on one side, I do on the other. Multiply by 3 over 1. The 3's cancel, the 1's cancel, x equal 27. So if you ever have a fraction as the coefficient, you multiply it by the reciprocal. Whatever you do to one side, you do on the other, that'll get x all by itself. Everybody understand that?
Mm-hmm.
Learn something new every day. Learn something new every day. So it's after 7. I'm going to go ahead and cut out because I have to got another session right after this. But any questions before we leave? Does anybody have a test coming up?
Mr. Tinley, I do it a different way and I get 6.
Well, that's
X
fine.
equals 6.
If it works
X
for you,
equal negative 6.
That's fine. If your way works, use your way. You know what I mean? If you understand that way and that's what you've been doing that way. I just know that as you get to more involved concepts, understanding what a reciprocal is will be very beneficial. Okay, so remember, if you have a test coming up, make sure you get with me so we can do that one-on-one so you can take your test the first time and be done. All right, everybody have a good evening. It's been a pleasure, as it is always. Everybody have a good night.
Good night.
Bye-bye.
Bye.